Hello and welcome back to Calculus 1, section 5.4 on working with integrals. Silly title, yes, but we copied from the book. What we are doing here is we're learning a couple of formulas which are helpful. They're not essential. In some later courses in mathematics, these formulas will help you skip a page calculation. Right now, they're just formulas that you can learn, but they're, as I said, not essential for survival at this level. Before we go and look at those formulas, we have to review the meaning of even and odd functions, which is something you learned a year ago in the basic function course. So we have something, it's called even function. And the even function had the property that f of negative x is equal to f of x. So that was the property of even functions. And as an example, we can test, let's say f of x is equal to x squared plus 6x to the fourth. The way to test this is you obviously look at the formula up there. You are supposed to calculate f of negative x and then see what that gives you at the end. So now when you plug in negative x, negative x to squared is going to be x squared because negative times negative is positive. And on the other one, you have 4 negative signs. That's still going to work out positive. And you are going to have f of x. So we reach the conclusion that f of negative x is equal to the original f of x once you work out all of the algebra. There's that lag. Perfect. So we have a notion that, if all of the exponents are even, you have an even function. Now, cosine and secant are also even functions. And the reason for it, you are going to see at the end of Calculus 2. So just, have to wait a little while. So that's about even functions. And now odd functions. So odd function has the property that f of negative x is equal to negative f of x. And naturally, this will be all even exponents. So let's say you have 3x plus 9x cubed, for instance. Whatever, 3x plus 9x cubed. And you immediately calculate f of negative x, which is when you replace each x with the negative x and you carry out calculation. So in this case, you get negative 3x, and then you have 3 negative signs, so negative will survive. And now you see that you can kick out a negative in front, and you have 3x plus 9x cubed, which is exactly what your f of x was to start off. And you have that f of negative x equals negative f of x, which we define as the odd function. Now in pre-calculus, we were teaching this and talking about the symmetry on the y-axis, symmetry on the x-axis, and so on. But, you have this formula to test. So all we did so far is review some concepts from pre-calculus so that we can finally write our formulas. And here is the formula. The first formula will go from negative a to a. So these numbers are always what we call additive inverses. If you add them, you get 0. So negative 2 and 2, negative 10 and 10, negative 100 and 100. They always have to be the same number with opposite signs so that when you add them, you get a 0. We call this symmetric interval. So integral from negative a to a of f of x dx is equal to 0 if f of x is odd. So if f of x is odd function, so we need this to be odd function. And if this is the odd function, you don't even have to bother calculating integral. The value of it at the end will be 0. So if you have integral from negative 3 to 3 of x cubed minus 17x to 21, like this, dx, you can immediately just write 0 because f of x is odd. On, and just put negative 3 to 3, which is symmetric integral. It's important for interval to be symmetric. This formula will fail if you change anything. If you have a non-odd function, it doesn't work. If you have, let's say, from 1 to 3, that's not symmetric interval, the formula will not work. So all of the features of the formula have to be there. Symmetric interval on these two, and odd function at f of x. So that's the first formula out of 3 that we are learning today. The next formula is if you have even function in there. So again, negative a to a f of x dx is going to be 2, 0 to a f of x dx if f of x is even. Now, you would say, well, I didn't, get much out of this because I still have to calculate integral. Yes, that's true, but you don't have to compute with negative a at least and get confused with all those minus signs. Now you're computing from 0. That's much easier to compute. So it's much easier to compute with 0 and double it than to actually use negative a in multiple x's in your answer to compute. So we are cutting out calculations a lot. An example again. Let's say negative 2, let's go for negative 4 to 4 of 6x squared minus 3 dx. So this would be an even function. And because it's an even function, we can rewrite this as 2 times integral 0 to 4 of 6x squared minus 3 dx. So now, integral of x squared is x cubed over 3. So this becomes 2x cubed minus 3x, computed from 0 to 4, and everything needs to be doubled. Come on, lag. There is a 2 in front. There it is. So you copy the 2, and then you integrate from 0 to 4. So as you can see, I don't have to calculate at negative 4. That's the advantage. Calculating a 0 with polynomials will just go away. So I have 2 times 4 cubed minus 3 times 4 minus 0. So we don't care. 2 times 4 cubed is 64. So 128 minus 12, which is 126. And that's 252. So we didn't cut out solving the integral, but at least we cut out a little bit on the work and we did not plug in negative 4. Now, do you see why is this called quality of life rather than some fundamental idea? Can you solve this without knowing the formula? Yeah, it's just going to take you an extra step because you'll have to deal with negative 4 rather than plugging in 0 where both terms go away. You earn nothing if you have e, because writing e to the 4 or writing e to the 0, right? They still stick around. Same thing with the cosine, right? Oh wait, hold on. You can't do this with e because e is not even. Great. Anyway, you can do it with cosine though. So what you have here is just a shortcut, a little bit faster way to solve a problem. Again, not essential for your survival. Yes?
Isn't that supposed to be 116, not 126?
What happened?
126, shouldn't it be 116? 120 minus 12?
116, yes, it is one. It's clearly 116. I'm not sure what the issue is.
It says 126.
No, it says 116. Look, look 116. It's clear. Look, clearly 116.
You were right.
I was just testing everyone. Yeah. I just want to see if anyone is paying attention. Very good, very good. Always. Good. And the third formula that we are going to have here is called the average. Now, this is useful. So this is the average value. And the average value of the function is calculated as 1 over b minus a integral a to b of f of x dx. We'll put this on a cloud. All right, this is your average value formula. And sometimes I have this also in a rotation for your projects. Sometimes I give a problem about rainfall, how many inches of rain, but I give a function rather than giving you data. In some cases, I can give the data. You can come up with a function looking at the data and then integrate. The idea is to calculate how much inches of rain you have in a month or 2 months or 3 months or half a year, which you have a function that shows the rainfall within 1 month. So if you just want the rainfall for January, your limits will be 0 to 1. If you want February, limits are 1 to 2. If you want February through June, right, you will start limits 1 through 6. So, you have multiple ways of dealing with this. And those limits, those would be your A and B, and then you would be able to calculate the average, let's say, rainfall. So if I want to calculate here, find the average value of the function on, let's say, 0 to 9 for f of x equals x squared minus 1, you just plug these numbers in. The average value is 1 over 9 minus 0, integral 0 to 9 of x squared minus 1 dx. And you just compute. This is 1 over 9, and then your integral here is x cubed over 3 minus x computed from 0 to 9. So we have 1 over 9, plug in 9, that's a 9 cubed over 3 minus 9, and then minus 0, no one cares. Now, there are cute ways to compute this rather than, immediately jumping to the calculator to see what 9 to the 3 is, because there are 9s everywhere. You have your 9 cubed over 3 minus, and you have to make this in a common denominator, as you can see. And now you can factor a 9, and you are left with 9 squared over 3 minus 3 over 3, because you'll need common denominator to combine them. So now these guys cancel completely. 1 over, oh, I could have canceled 1 over 9. I don't have to do the common denominator. I don't have to do it. I can just keep this as a 9, and then when I factor 9 out, it's just 1 left. Because 9 squared now is 9 times 9, but one of the 9s can cancel with a 3, so you just have 26 as the answer. So 26 is the average value for the function, which is cool. This can be quickly turned into the mean value theorem for integrals. And if you remember the mean value theorem, there was that C that we were looking for, which is exactly the same as the average or the mean, same idea, which is your 1 over b minus a, integral a to b of f of x dx. So you can find that value C, where you have the average value for the integral. So find C for f of x equals to, I don't even know what to put anymore, 1 plus x to the 4th on negative 4 to 4. Okay, so f of c is equal to 1 over 4 minus negative 4, integral negative 4 to 4 of 1 plus x to the 4 dx, and this is equal to 1 over 8 integral negative 4 to 4 of 1 plus x to the 4 dx. Now I hope you guys see that this is even, so you can quickly make this into 1 over 8 times 2 times integral 0 to 4 of 1 plus x to the 4. Again, this happens sometimes. It doesn't happen all the time that you have a even function and you can make your life easier. In this case, it lined up, so that's nice. 2 and 8 will cancel. You will get a quarter in front. And now you have your integral of this, so that's 1x plus x to the 5 over 5 computed from 0 to 4. That gives us, when we plug in a 4, you get a 1 quarter, plug in 4 plus 4 to the 5th power over 5, and then minus 0, so we don't care. We can factor out one of the 4s, and if you factor out one of the 4s, so factor out one of the 4s, it will cancel. So I'll just cancel the 5, put the 4, cancel the 4, put the 1, and cancel the 4 in the beginning here. So you just get 1 plus 4 to the 4th power over 5. So that's 256. So 1 plus 256 over 5. And when you add 5 to both, that's 5 over 5. That's 360. Wait. 5. So that's 261 over 5. If all calculations went well. Yeah, let's call this good. So that's the section 5-4. 3 formulas. The third formula, it's the formula for the average, which also has a name as the mean value theorem for integrals. So that's section 5.4. And after a short break, we're going into the most important, right, 5.5.